Hello friends, our operating system subject has Unit 5 Memory Management. In our previous lecture we have seen part 1 of it. In that we discussed the fixed partitioning and variable partitioning. Now today in this lecture we will see part 2 of it. These are the course outcome and unit outcome of Unit 5 and these are the contents. Today in this lecture we will see what is swapping and what are the free space management techniques. So first we will see swapping. A process can be swapped temporarily out of memory to a backing storage, means to the secondary storage, and then brought back into the main memory for the execution. The backing storage, which is the secondary memory, it is the fast large disk which is enough to accommodate the copies of all memory images for all users. It must provide direct access to these memory images. In swapping, we are performing two operations, roll out and roll in, or swap out and swap in. Swapping is used for priority-based scheduling algorithm. We have seen in our fourth chapter priority-based scheduling algorithm. The swapping help us in that type of scheduling algorithm. Lower priority processes need to be swapped out to the backing storage and higher priority processes need to be loaded into the main memory for the execution. The major part of the swap time is to transfer the process from the main memory to the secondary and from the secondary to the main memory. The total transfer time is directly proportional to the amount of memory swap. The modified version of swapping are found on many systems. For example, Unix, Linux and Windows. This is the diagram of the swapping. Here, this is the main memory which has at the lowest location the operating system, and this is the user space area, and this is the backing storage, that is the secondary memory, that is the disk. There are two processes at the backing storage, P1 and P2. Now we are performing swap out, that is roll out, and swap in, that is roll in operation here. When we are transferring a process from main memory to the backing storage, it is called as swap out. And when we are transferring any process from the backing storage to the main memory, it is called as swap in. Now we will see free space management techniques. Now when we are storing back our process to the backing storage, it is needed to search whether there is free memory available into the disk or not. For that, there is use of free space management technique. Now, since the disk space is limited, we need to reuse the space from the deleted file if possible. If we are using write once type of memory, at that time free space management is not required. But if we are using this which can be writable many times, at that time we need to use the free space management technique. To keep the track of free disk space, system maintain the free space list, which lists all the free blocks, that is the blocks which are not allocated to any file or directory, and that can be allocated to the new file when it is stored into it. To create a file, we have to first search the free list and allocate that space to the new file. The allocated block number is then removed from the free list. Once we have allocated that block of the free list, means we have stored data into it. Now it is not free, so we will need to remove that block number from the free list. When the file is deleted, when any file is deleted, now that space of that file will become available for the other files and can be used by other files. So the block number of that particular file can be added to the free space list. There are two methods for the free space management. First is bit vector or bitmap and second is linked list. Now bitmap or bit vector is the strategy in which a reserve memory area is used to indicate whether the blocks of the disk are allocated or free. Now this is just like a reserve area where each bit will represent for a single block of the disk. So if there are 2 raised to 10 block in our disk, so we will need 1024 bits to represent whether that blocks are free or occupied. If the block is free, we will indicate it by 1, and if the block is occupied, we will indicate it by 0. Now if the disk size is larger, then this bitmap size will also become very larger. Okay, now here is one example for us. These are the block numbers which are free and can be allocated by the file. Now we can represent the bitmap like that. For the block number 0 and 1, as it is allocated is not there in this list, so we will put 0 in the bitmap. Okay, now the block number 2, 3, 4, 5, these are free, so represented by 1. Again 6, 7 are allocated, so represented by 0. Again 8, 9, 10, 11, 12, 13 are allocated, so represented by 1. And after that again 14, 15, 16 are allocated, so represented by 0. And 17, 18 are free, so allocated by 1. So in this way we will put either 0 or 1 for allocated and free blocks. So this is the bitmap or bit vector for this particular example. Now suppose I have one file and I want to allocate that particular file. So I need to find that particular address. So the address calculation can be done by this particular formula. What is there? The number of bits per watt, means how many bits are there per watt, into the number of zero value words. Now here there are 2 zero value words. So that the multiplication of that and plus the offset of the first bit, that is the offset of these, will be added to it. So it will give the exact location of the free block in the memory. So the bitmap requires the extra space to allocate zeros and 1 of the block. It is easy to get the contiguous files in if we are using the bitmap. This is very simple and efficient. The Apple Macintosh OS use this method, and if we are using grouping of the similar type of bits, this will reduce the size of bitmap. Means if we are having continuous 1 or continuous 0, we can make the grouping of that so that the bitmap size will get reduced. And we must keep this on the disk, and the copy in the memory and disk may differ. This is the problem of the bit vector or bitmap, that the copy of the memory, main memory and the disk will be varying. So the second method is the linked list. Here linked list is maintained to give the list of free blocks. So the header will have the starting address of the linked list. Okay, now the first block, the address of this particular first block will be in the header, and the rest of the blocks address will be linked using the by putting the address of the next block into the last 2 bit of the previous block. So in this way the linked list of the free blocks is maintained and the last block address will be null to indicate that there is end of the free list. Now suppose any file is need to be allocated to the disk. So at that time this linked list is searched and the blocks from the linked list will get allocated and the file will get stored and the next free list will get updated. Okay, so the starting block will be removed from that free list and the header will be shifted to the new blocks. Okay, the free list cannot get continuous space easily. With this linked list implementation we cannot get the continuous space easily, but here there is no waste of space and the problem is that if any pointer is get missed, at that time this linked list strategy is not good. No separate method is needed for pointer and fat is used for it for implementing this linked list. So this is all about the swapping and free space management technique. So